Did you know that realigning the ODU is one of the top 2 fix codes on all service calls and repeat service calls? Well, it's true, and it's up to you, the professional installer, to make sure each dish is aligned to peak signal strength. It doesn't make sense to rush on a job only to have to return to fix a problem and have to work with a dissatisfied customer within 60 days. By taking the time to complete all the right steps and making an investment in the right tools and equipment, you'll be able to do your job better, faster, and easier. And improve customer satisfaction with both you, your company, and DirecTV. I'm Patrick with the DirecTV Technical Training Department, and for the next few minutes, we'll be covering the procedures, techniques, tools, and tips that'll help you align your skills to maximize peak efficiency. Before you begin, you'll need to find the azimuth, elevation, and tilt needed to align the dish. You should already have this information before you arrive at the customer's home. If for any reason you can't obtain this information, you can call the DirecTV ISS group. Write this information down. You'll need it to align the dish. Azimuth is used to determine the left and right or horizontal adjustment of the dish. Elevation refers to the up and down or vertical adjustment of the dish. Now, tilt refers to the clockwise or counterclockwise rotation of the dish based on the scale on the back. During the exterior site survey, many common errors can be made while determining the best location to install the dish. These include not estimating new construction, landscaping, and additions to existing buildings in the vicinity. Placing a dish too close to the house where water runoff from rain can hit the dish, disrupting signal flow. Placing a dish where foot traffic can block signal or where the dish is subject to being knocked out of alignment. Placing a dish where car radar detectors can interfere with the system. Placing a dish where snow or ice accumulates. Placing a dish over chimney or exhaust pipes. Not estimating foliage that will appear in the spring and future tree growth. A suitable antenna site requires a stable mounting surface, a distance of 110 feet or less for RG6 cable from your antenna to your receiver, a grounding source nearby that meets NEC requirements, an elevation angle clearance above the horizon, and at least an 18-degree window span of clearance in the southern sky to the satellites from 101 to 119 degrees with an unobstructed view to all satellite locations. This means there can be no trees, leaves, or buildings in the line of sight between the antenna and the satellites. The 2 tools you'll need are a compass and an inclinometer. Most installers are familiar with the use of a compass. A compass is used to find the azimuth from the home to the satellite. An inclinometer indicates the degree of elevation from a specific location to a satellite. Most installers use an inclinometer-compass combination like this one to determine the azimuth and elevation for aligning a dish. Standing near where the dish will be mounted, determine the azimuth to the satellite using the compass. If you live on the west coast, the satellites will be to the south-southeast with a counterclockwise tilt. If you live on the east coast, the satellites will be to the southwest with a clockwise tilt. Next, use the inclinometer to determine the elevation in degrees. On some inclinometers, there are 2 sets of numbers, percent and degree of elevation. For the purpose of alignment, we use the degree of elevation. While looking through the inclinometer, keeping both eyes open, tilt your body back until the scale displays the elevation setting you received from the menu. If possible, it's a good idea to allow for an extra 10 degrees of unrestricted view on either side of the required 18-degree window. This provides some leeway and helps to eliminate the possibility of any future obstructions. Keep in mind that if you cannot get the extra 10 degrees on either side, it should never be grounds for canceling a work order. Although DirecTV has used a variety of ODUs, in this video we'll demonstrate assembling, aligning, and peaking our most common ODU, the 18x20 multisat. While the ODU is on the ground, it's a good time to preset the elevation and the tilt using the information you wrote down from the IRD setup screen. At the back of the antenna assembly, loosen the tilt nuts, then set the tilt using the number you obtained earlier from the antenna pointing menu screen on the receiver. Next, tighten the tilt nuts. Now it's time to set the elevation. At the side of the antenna assembly, loosen the 2 elevation nuts. Preliminarily, set the elevation adjustment using the information you obtained earlier. Align to the elevation scale using the metal edge. Do not use the washer or the bolt. Tighten the elevation nuts, but not completely. This is a preliminary adjustment, which you'll need to fine-tune later. Start by mounting the base securely. The mast base must be sturdy so the antenna does not shift under extreme weather conditions or under its own weight. Mounting is preferred on a wood stud, joist, rafter, or masonry. Never mount the dish on any type of unstable material such as unsupported stucco, unsupported aluminum or vinyl siding, or unsupported composite paneling fiber, particle, or strand boards. Remember, you can locate roof joists by using a stud finder. The #1 mistake an inexperienced installer makes when installing the dish is not plumbing the mast. Plumbing the mast is critical to receiving optimal signals. Failure to align it properly will make it more difficult to acquire signal and an increased tendency to have signal outages in adverse weather. Taking the time to plumb the mast correctly will make the alignment process easier, faster, and more precise. The ODU can be plumbed 2 ways. First, by loosening the bolts and holding the base to the mast, then using a bubble level. When the bubble and the level is centered on both the vertical and the horizontal, the mast is plumbed. The second and easiest way is to use the built-in bubble type leveling tool called an Easy Align mast. The mast is designed in such a way that it will rotate in every direction, allowing the installer to mount to almost any mounting surface. Before using, make sure the bubble level is seated properly. Loosen the 4 mast bolts slightly. Move the mast up and down or twist side to side until the bubble and the bubble level is centered. If the mast is mounted in a location where it's difficult or dangerous to view the bubble level, use a small mirror or a plumbing level instead. Do not risk falling from a roof or other high places. When the mast is plumbed, and while still keeping hold of the mast, tighten the 4 bolts with a 7/16 wrench in the other hand. Always be sure to adequately tighten all bolts and use the correct hardware. It's suggested that you leave the bubble level in the mast to make plumbing easier if it should be necessary in the future. Using the information obtained from the receiver and a compass, point the dish to a good starting point and pick a reference point in the distance such as a tree or a building. Be sure to keep the compass away from any metal or electric motors so that it will work properly. Now it's time to set the azimuth. Though you can use an IRD to generate all the necessary control signals, it should never be used to align an ODU. All installers must use a signal level meter. There are a variety of meters available on the market today. Any of these will help you quickly align an antenna and verify signal levels. These all work basically the same way. All of them are battery operated, so you need to make sure yours is fully charged every day. Most have a charger that operates off 110 volts, so they can be charged using a standard electrical outlet. Most also have a cigarette lighter adapter, which will allow you to charge your meter in your truck. Here's how most digital signal level meters work. Once connected to the LMB, the signal level meter provides a voltage that selects the polarity you want to test and a 22 kHz tone to select the 72.5, 110, and 119 satellites. On this applied instrument's dual buddy, the signal level is displayed by LEDs that illuminate as the signal level increases. The dual buddy has 2 inputs which help you align the tilt of the older 3 LMB multi-sat dish so you can maximize the performance viewing the satellites between 101 and 119 without moving the jumper from one LMB to another. With the 18 by 20 multi-sat ODU, a single input will view all satellites between the 101 and 119, provided the meter you're using can produce the 22 kHz tone. In this application, we're using a bird dog meter with one input. The bird dog can be pre-programmed to read signals from any DirecTV satellites. Though the meter comes pre-programmed, reprogramming is done online, so as orbital slots are added to our lineup, the meter can be upgraded to incorporate any new satellite locations. Instructions are included in the directions provided by the manufacturer. This meter will read the signals from adjacent satellites if you're looking directly at it. However, it will only lock onto the satellite you've programmed into the meter. When you find the satellite that is programmed into the bird dog meter, the LCD window will display found and the tone will change. The bird dog is connected the same way as the Dual Buddy. Run a jumper from the output port of the LMB to the input port on the front of the bird dog. Push the on button and hold it for 5 seconds. The meter will come on. Using the arrow buttons, toggle to the satellite you want to receive. It's best to peak with Sat A at 101 first. When you fine-tune the antenna to one satellite, the other two satellites should be aligned automatically. Now align the dish using slow right-to-left motion until your display reads found. Once you sweep through the peak signal point on the screen, you may want to swing past the peak a couple of times. You should be able to achieve a signal of 90 or better under normal conditions and only slightly less if it's raining. Mark the mast and the antenna bracket point with a pencil. Toggle to the next satellite and align to peak that signal. Keep the audible tone on the meter on. This will allow you to hear if the antenna is accidentally knocked out of alignment while tightening the bolts. Now you can fine-tune the elevation. This can be done by loosening the two elevation nuts, then moving the dish up and down slightly in 2-degree increments while observing the signal strength on the meter. Find the peak and tighten the two elevation nuts. Unlike elevation and azimuth coordinates, there should be no fine-tuning of tilt. Doing so will cause alignment difficulty, and even if a signal is acquired, it will not be optimal. Remember, there's only one tilt setting per given zip code. Once you've finished aligning the dish, be sure to tighten all adjustment bolts and nuts on the antenna. Remove the signal level meter and connect the receiver cable to the switch. After the dish assembly is properly aligned and tightened, place several marks on the azimuth, elevation cap, and mast with a permanent marker. This will allow for a quick and easy dish alignment if for any reason the dish needs to be realigned in the future. Confirm the final peak signal reading at all satellite locations using the setup menu on the receiver. Also be sure to check all satellite transponders for signal strength as well. You may notice that the reading on the signal level meter will be similar, but not the same as the reading you get from the receiver. The signal strength and picture quality at the receiver is most important, so be sure to check all of the receivers in the home. As you can see, the process of mounting and aligning a dish requires many steps, starting at the very beginning of the installation during the site survey. Now, every step must be followed to ensure the best performance of the system and to avoid signal interruptions and unnecessary truck rolls.